Two-sided marketplaces are a great way to resolve supply and demand inefficiencies. There is such high demand for great programmers, but there is only a limited supply. So why would it make sense for a great developer to use a terrible tool like a job search engine? That's why I love Hired.com. Developers can sign up at Hired.com/software engineering daily and be connected with 5 great job opportunities at companies like Stripe, Uber, and Facebook. If you're a developer, you shouldn't settle for a mediocre job. And I know this from personal experience. It will stunt your career growth. Hired will give you a $2,000 bonus if you find a job. And if you go to Hired.com/software engineering daily, you will get an additional $2,000. It costs you nothing to try it out, and it's a fun process. I urge you to try it out. Srini Kadamati teaches and writes about data science at Dataquest and has worked as a data scientist at several companies in the past. Srini, welcome to Software Engineering Daily.
Thanks for having me, Jeff.
So we've got a bunch of topics to discuss today: data science, data engineering, TensorFlow, other topics. But I want to start by talking a bit about what you are working on, which is Dataquest. We did a show with your Dataquest coworker, Vic Paruchuri. So if listeners are curious, they can listen back to that episode. From where you sit, what is Dataquest and what are you working on there?
So the mission of Dataquest is to allow anyone to be able to work with data. So we basically provide an interactive learning platform where anyone can go with very little experience, in most cases no experience, learn how to write code, how to work with data, how to kind of understand and grasp the concepts behind statistics and machine learning, data visualization, etc., and basically how to go from zero to getting stuff done with data.
How big is the market of people that want to learn data science?
That's a really good question. So our hypothesis is that the size of the market of people who want to learn data science is really big, and we think it's way bigger than, for example, number of people who want to learn how to build software. There's a lot more people who, in some way, shape, or form, work with data. There's a lot more people. SQL is probably the most popular programming language, not Python or Java. And there's so many people who work with data that they're using kind of a variety of tools. Data science is incredibly broad. And we've not really seen a great solution for kind of figuring out what you don't know and kind of going about learning that. I think Linda and Pluralsight do a great job in the kind of general software engineering space. But we have yet to see a really good kind of product in the data science space, and we hope to kind of be that product.
And part of the way that you're solving that problem is by developing an in-browser experience, sort of like a gamified experience. How well does that in-browser experience that you've created at Dataquest, how does that translate to the day-to-day work as a data scientist?
Yeah, that's a really good question. So we try to get as close as possible. And so we basically, at each step of the learning phase, try to figure out what makes the most sense. So in the kind of introductory Python and pandas and statistics lessons, the interface resembles a little bit more of kind of like an IDE. But as like kind of, we've just introduced guided projects, for example, where the interface, we have 2 different interfaces, but one is kind of this mix of shell, like a live programming shell, and actual like code snippets, like an IDE, as well as a kind of interface that resembles very closely the Jupyter Notebook or the IPython Notebook interface. And so those interfaces are kind of to help people transition from the kind of interface I mentioned earlier, where we're kind of mixing text and code and you're running and evaluating code to see if you got it right, to kind of the more day-to-day workflow for most data scientists, which is the kind of IPython Notebook or Jupyter Notebook, which is now what it's called, workflow. And if you're not familiar, Jupyter Notebook is essentially a project that has both kind of a kernel and kind of eval loop along with a notebook format. So you can kind of mix explaining and kind of teaching concepts or exploring concepts with kind of live code that's executed live. So it's pretty great.
And as many shows as we've done on Software Engineering Daily about data science and data engineering, I think it's still something that's worth delving into to provide some definitions. You were actually the first person to point out to me that there is this bifurcation in roles between data science and data engineering. I think many people listening probably don't know the distinction between these two roles, and it's kind of an evolving theme in computer science, in software engineering. How would you define these two roles, data science and data engineering?
Totally. So a data scientist is essentially someone who, more or less is trying to use data to do science. They're primarily interested, they see data as a tool, and it's a way of understanding science. It's a way of understanding some process. And so they're primarily concerned with the kind of analysis piece. They're a little bit more interested in the theory, the math, and they're fundamentally kind of interested in the business problems that you can solve with data. A data engineer is someone who's spent a lot more time figuring out how to store data, how to collect data, how to kind of supplement the data scientist. And so that's kind of the difference in the role, which is basically, the data engineers are very focused on the storage, kind of how to share the data, how to work with the data. They're a little bit less kind of informed on how the data is actually used, or they themselves are not that interested in using the data to reach decisions. And so that's versus the data scientist is way more interested in actually what the data can tell them. And so that's why it's a really great kind of pairing that's kind of evolved over time.
Separation of concerns.
Exactly.
So when a product company is getting started, generally, it's like, we can even talk about Product Hunt, for example, or name your hot startup. Originally, they're focused very much on their core offering, which probably they're not thinking as much about user data. They're not thinking about the types of ancillary data that their product is giving off, sort of. So eventually, the product company starts to gain traction, and early on they did these companies don't really have data scientists because they're so focused on their core product. But as time goes on, they need to take advantage of their data. So what is a typical roadmap when a company decides, okay, we're starting to scale, we need to hire data scientists, or do they need to look at hiring data engineers first? What are the best practices to starting to accumulate a data organization?
Yeah, that's a good question. I think it depends a lot on just how the company evolves and just the specifics of what the company's doing. I think it's very similar to the way it's done in engineering, where at the beginning, kind of the initial engineers are doing everything from QA to testing to live production stuff, DevOps, that kind of stuff. And then over time, you have, as you mentioned, the separation of concerns. I think more or less it's very similar in data science, and I think it's basically an evolution in complexity. So in the beginning, you're really only collecting really basic data that can fit in one SQL database. And then over time, that kind of evolves. And essentially, data science is all about understanding processes. And I think the evolution matches the evolution of the complexity of the process. As the process gets more and more complex, as you want to measure more and more, and you want to understand more and more about what's going on in your software product, you want to build more sophisticated solutions. You want entire teams possibly dedicated to just a product, to understand just how one product works. And so I think that evolution is kind of very natural. It's very dependent on how the product and the team and the company is structured. But you're totally right that in the beginning it really is just kind of one guy, maybe part-time, and then it's someone doing it full-time, and then it's kind of a team. It's really quite interesting, and yeah.
So no best practices yet, maybe, because I guess it just depends on the stack and the situation and how important data science is to the organization.
Yeah, priorities. So I wouldn't say there's no best practices. Jeff Hammerbacher and DJ Patel definitely have really good both talks and kind of O'Reilly books about how to kind of really do data science, how to build data science teams. There's definitely kind of war stories that you can learn. from those guys. And there's a bunch of great talks as well. I know Software Engineering Daily has obviously kind of interviewed a lot of people who like from Spotify, Netflix, and you could hear about their war stories as well. But I think that's exactly what it is. They're war stories. Right? There's definitely some lessons you can take away, but I do think it does end up being a little different for each company.
So one of the shows we did do was I think it was Insight Data Science, where no, I'm sorry, this was Zipfian Academy, now Galvanized Data Science, where they were talking about how there's this misunderstanding kind of in some of the like hiring facilities of a company oftentimes, and what the realities are of what a data scientist is capable of. So how this manifests is companies will often post job positions for data science unicorns that say, we're looking for a data scientist, must know MySQL, must know Spark, must know X, Y, Z, Z prime, Z double prime. What is the minimum viable set of technologies that a data scientist needs to know and that a data engineer needs to know?
So I think those are two different kind of questions or ideas. The first one definitely, I think, is maybe just a failure of understanding what a data scientist does. So the kind of the buzzwordy job post, I think that's a good signal for kind of a not so developed or kind of inexperienced data science culture within a company. And I think the places like Netflix or Spotify that do have good data science cultures and established processes, they know what people want to, or people are looking for in job postings, and they try to avoid just loading it with buzzwords. The second part is an interesting question. I think, as I mentioned earlier, it does really depend on the company. For example, Google has this position called quantitative analyst, which is kind of their word for data scientist, and those guys, based on my understanding, work a lot in R and Stata and that kind of stuff, and so. Those guys, they focus a lot more on quantitative concepts and your understanding of kind of really hardcore theoretical ideas over, say, your experience with Spark. And so it does definitely depend on the company. But I will say, obviously, kind of based on what we teach at Dataquest, we're pretty big believers that like every data scientist and data analyst needs to know Python and SQL at the minimum. Those are kind of, in our opinion, and what we've seen as well, talking to companies and people who've worked at companies, the two most kind of common languages that people use. Definitely SQL. We do teach some R, and we still see a lot of organizations that do use R. And so for people who have more of that quantitative, hardcore background, R tends to be the more common tool. For data engineering, that's an area that's evolving so quickly that it's actually quite interesting. I think it does depend a lot on the company. So if you want to work at a certain company and they only use Spark, for example, like one of my previous employers, then learning Spark is like the way to go. But I do think for data engineering, the most important language to know is Java and the JVM, because most of these distributed processing tools are built using the JVM. And so I think having good mastery of the JVM, learning at least Spark or Hadoop, and just being familiar with these other kind of libraries, a lot of the stuff you guys have talked about, I think is kind of a minimum.
Are there any more job responsibilities within these data science and data engineering verticals that will get unbundled further? Like, are we going to have assistant data engine, not assistant data engine, I don't know, data, could you see this tree break down even further?
A data wizard? Yeah, I definitely think so. So, for example, I'll give you a Dataquest. We actually have a data analyst track as well, and we're actually pretty big believers of the data analyst role. There's a lot of places like economic consulting firms, or even at Fitbit, where they actually have a different role for a data analyst, a data scientist / research scientist, and a data engineer. I think in kind of more mature data science organizations, that kind of trifecta of kind of this person who's like working with data, they're more of kind of a business intelligence person, you can say. They use a lot of maybe Python, some R, SQL, Excel, Then you have kind of this more science role, which is usually PhDs, but not always the case. At least a master's degree in most cases, who are way more focused on the models. And then you have this kind of a data engineer person who is more focused on the infrastructure and DevOps and that kind of stuff. I think we might see more. We might see data engineer get broken down more between kind of a DevOps and a role that's maybe more tightly coupled with data science. So it's
data ops.
Yeah, maybe data ops. I don't know. You can kind of take the credit for coining that phrase when it blows up, I guess. But yeah, so I definitely think that's there. I think the last role that's incredibly underappreciated is presentation, visualization, explanation. I think we will see this kind of and we're starting to see it, like this hybrid of a data visualization engineer and a designer who kind of is really good at who can do blog posts, who can kind of communicate, like create really good reports, and kind of the more explanatory human side of data science is still very, I think, underappreciated.
Interesting. Yeah. So, I mean, that raises an interesting question. Like, how much of the work of the data scientist is, or how much of the responsibility of the data scientist is generating the right queries versus explaining the meaning of those queries, I guess, or explaining the statistical, explaining the conclusions that one should draw off of the results. Interesting. Okay, well, let me ask you a more concrete question.
Sure.
So a data scientist, like, needs to maybe know some SQL versus knowing some Spark. So, as somebody who has just talked about Spark but hasn't actually worked on it, which is admitting probably a sin to some listeners, but nonetheless, it's the truth. I've not worked with Spark. What do I need to know about Spark? What do I need to, like, what does a Spark query consist of, and how does that differ from just a SQL query?
Yeah, so that's really interesting. So Spark is not quite. So Spark is still kind of a framework, you can think of it. I mean, Spark is really, as Matei said, it's really just a generalization of MapReduce. It's actually, I would say, it's much closer to a programming language than like a query specific language like SQL. And so, like, for example, you can use Spark just for data processing and not even do any data science per se. You can just use it to kind of store and manage data without even doing any data science. I think. Sorry, I forgot your original question.
Well, I was just I remember when in the first real life conversation I had with you, you were talking about your work as a data scientist at one of your previous jobs, and you said that working with Spark from your end as a data scientist was not difficult at all. It was, I think you drew the analogy between working with Spark and just like entering SQL queries. So maybe I'm misremembering our conversation, but I'm just curious, like, I've entered SQL queries before. How much of a jump is it to enter a Spark query?
Yeah, I think it is. I think they are quite different. I think the more appropriate jump is between the IPython notebook flow and the Spark flow. There's a few reasons for this. So as I mentioned earlier, a lot of data scientists do use the kind of Jupyter Notebook / IPython notebook workflow to kind of interactively explore data. And I think what the Spark guys really focused on is they have a project called PySpark, which is basically uses this library called Py4j, and it allows you to write Python code along with, it has this PySpark library and a spec. But you can basically write Python code and it'll generate kind of code that runs on the JVM. And so it's kind of a way to interact with like a Spark cluster completely using Python. And so I think what's really great about that is if you know Python, you know Spark. I think that's essentially the leap that I might have mentioned. I think, if you still only know SQL, you still may not appreciate like just how programming works, like error messages, and there's still a lot of kind of programming related stuff that I think if you just know SQL, you may not be all at home with and comfortable with Spark. But I definitely think if you're kind of used to this IPython notebook workflow, you've done some pandas before, and you've kind of generally worked with data, this notebook style format, I think it's really easy, maybe a few days tops, to make that transition to the kind of PySpark workflow. I think that's maybe what I may have been referring to.
Okay, got it. So many of the people who listen to this show categorize themselves either as software engineers, they're either back-end infrastructure or they work on front-end web frameworks. I don't think I have a ton of listeners who categorize themselves as data scientists or data engineers. And, ostensibly, many of the engineers that are just doing back-end infrastructure or front-end web framework, the people who I believe are the bulk of the listeners, they don't need to know much about data science or machine learning. But if they were going to learn some material, what are the things that they absolutely need to know about data science and machine learning?
Yeah, that's a good question. I think the most important thing to know about data science is just kind of the data skepticism. It's just kind of I really think data science is like design in the sense of it's a way of thinking. And so just like you can look at any process object in the world and understand maybe the trade-offs that were made, the design decisions that were made, I think you can think about any kind of, maybe New York Times headline or any kind of report that you might see at work, or kind of some diagram that some MBA came up with at your workplace, and just think about like what were the assumptions that were made when that report was created, or even kind of like why you're working on something. So I think one thing that's really interesting that I think LinkedIn, for example, did really well was they made data scientists super important and gave them a lot of autonomy in the organization. And so there's a well-known story of Peter Skamorch, who I think it was Peter, who kind of came up with the who you might know or who you should friend or whatever feature on LinkedIn. And that was kind of a data scientist who came up with this feature that really drove a lot of engagement. And I think that kind of marriage between kind of data science and product engineering is really healthy. So I do think trying to figure out more about like why, for example, if you're an engineer, like why you're working on a certain feature, or is this the right thing to focus on, and just having that kind of skepticism and trying to like understand, like show me the data, like why is this the right thing to do. I think that's just a healthy attitude to have in general. I think that's probably the biggest kind of takeaway and important kind of philosophical thing about data science that everyone should learn.
So are you saying that organizations should not work on features if they can't back up the justification for that feature with data?
I think maybe not quite as black and white. There are many cases where, like you actually don't have the data and you still have to make a decision. There's a great article talking about kind of being data informed versus data driven. I think in many cases, when you're doing something completely new, it is kind of hard to really have like, let's like do a bunch of data analysis and figure out if it's right or not. I do think every decision can be data informed. So what are some kind of general things that are going on in the business that like that makes sense for a certain decision? Or even more so, like in the kind of iterative engineering process, can you push something out quickly and then use data to measure people's reactions to a new feature, or clients' reactions to a new feature, or something like that? So I think I think that always has a role to play. It may not be before, it could be after in some cases, but I do think looking at the data and trying to see how it can inform and guide your decisions is super important. Because if you try to quantify everything, you could go wrong as well. So there's sometimes you do have to kind of pick a fork in the road and just when you're at a fork in the road, you have to pick a path, and I think you have to go with something. But at least kind of make sure that you're monitoring and ensuring that it is the right decision.
Engineers love automation, and Wealthfront automates your investing. As a software engineer, there are certain processes that you want to execute no matter what, like integration tests during a build. you wouldn't execute integration tests manually. You would use a continuous integration tool like CodeShip or Jenkins to automate your integration tests. Wealthfront is a tool to automate investing. Just like a continuous integration tool runs your tests automatically, Wealthfront can reinvest your dividends automatically and perform tax loss harvesting automatically. To get your first $15,000 managed by Wealthfront for free, go to wealthfront.com/sedaily and get started with Wealthfront's layer of automation on top of your portfolio. Wealthfront.com/sedaily. Check it out. It would support Software Engineering Daily, and you will get $15,000 managed for free if you sign up. Automate your investing. Get back to the things that you can't automate, like writing code. So you mentioned this New York Times headline stuff and being skeptical of that. And, one of the things I think about is, oftentimes with, New York Times medical section, for example, or some kind of scientific report, what happens is, you have a study that gets published and it will say something like, we've realized that this bacteria has a 30% chance of doing X.
Right.
And it gets translated into a New York Times headline of bacteria causes this. Whereas actually it's just a 30%, 30% incident or correlation rate or whatever. And so what I'm curious about is like, do you think that as data and data science permeates the public awareness at an increasing rate, do you think we'll have headlines and sound bites that have an increasing granularity of truth to them? Or do you think that this kind of information condensation into a headline will just continue?
Yeah, I mean, the headline thing is interesting. I'm not so sure if the headlines themselves will get all that better. I think there's a brand kind of market piece to it. I think, for example, like Vox Media's headlines, I think are way better than maybe BuzzFeed's. But I don't know, that could have changed. So I think it also depends on the target audience and kind of what they're going for. But I do think overall, more and more publications are using data and they are using graphs in the actual explanation, in the actual post itself. So the headlines, because of the way Twitter and Facebook work, and there's kind of all these other market realities where maybe headlines could still drive the eyeballs. But hopefully when people, the kind of reasonably intelligent people who actually want to dive in, even if it's not all the way to the source article, but at least, or the source research paper, but at least read the paper, read the post carefully. Hopefully, and we are seeing this with kind of New York Times and a lot of other Vox media as well, where they are including a lot more graphs, a lot more data links to the source, data sets sometimes. I think 538 is the gold standard.
Yeah.
Literally
yeah,
every...
Yeah,
go ahead.
Well, this comes back to what you were saying about the design importance, the data translator or data presentation layer specialist or whatever that role is.
Yeah, totally. I think the emergence of the role data journalist. I'm sure if you go to Google Trends, you'll see that there's a huge spike in the last 10 years where there's like this entire profession of just people who are like kind of semi-computer scientist / engineer, semi-stats person, and semi-journalist. And it's kind of this like really interesting unicorn maybe, but really kind of intersection of skills where it's all about storytelling using data. And I think I think all the modern publications have really embraced that. I think 538 and New York Times have really led the charge. They have really good interactive graphics teams, and I think they have the highest quality work. But we're seeing this kind of more and more where everyone, if you go back 20 years, people maybe cared less about graphs and data, but now people are demanding data. There's some great polls and studies that show that kind of millennials especially really they like seeing graphs, they like seeing data, and that's somehow more convincing. The danger, however, as I said earlier about over-quantifying, is that people use data to tell the wrong story. So there's still that needs to kind of balance out as well, because you can definitely use you can get the data to say anything you want, right? And so
Yeah, I've definitely seen some really interesting blog posts about like graphs that totally misrepresent the truth just because they use like interesting angles and stuff.
exactly, yeah. So there's definitely, I think it's an evolution. It's going to take maybe 50, 100 years. It's really kind of, but I think I think where we're at now is relatively healthy, and it's great to see. 538 is an entire publication that uses data in pretty much every single post. That's like, I don't know if you could have done that 30 years ago. Like, I don't know if there was even an audience for it. And I think that they're kind of the pinnacle of that. But even kind of there are entire even kind of publications within large media organizations, like the City Lab. I think that's the Atlantic. The City Lab is very data driven as well. So I think we're starting to see a lot of it, and I'm really thankful for it. I think it's a really exciting time just in data science in general.
Yeah. So speaking of journalism, I mean, you're a listener to Software Engineering Daily, and I would love to get your feedback on what are the areas of data science and data engineering that you would like to see covered more, and what are the things that I don't cover well enough? Like if you could navigate to softwareengineeringdaily.com and you click on it and you see like some articles and you see a podcast, what are the topics that you wish were covered more?
Yeah, that's an interesting question. I think coverage of kind of the data science process would be more interesting. So there's a lot of great coverage on kind of libraries, tools, and since it is a software engineering podcast, I mean, rightly so, there should be a lot of focus on the tools and the software products themselves. But I think to delve past, to go deeper into data science, I think exploring a lot more into how data science is actually done, the workflow. I know when you interviewed the Spotify guy, he had some kind of good explanation of what his day-to-day looks like. I think that's really important and really interesting. Even questions like what are the most common algorithms that data scientists and data engineers work with. I think if you read the headlines, maybe you don't know much about data science, you might think it's all like deep neural networks and like crazy fancy
Isn't it?
AI stuff. But you'd be surprised just like how much of it is just counting and like regression and just like really not super complex techniques. 90% of data science is not kind of these really fancy models that you'll see. So that's really interesting. I think letting people kind of get aware of that is, I think, super important. Yeah.
So when you think about the episodes that make your ears glaze over, or the episodes that really like pique your interest the entire time, is it about the topics? Is it anecdotes? Like, do you enjoy like the Spotify episode when we talked about kind of Spotify's data science in practice? Is that more interesting than going down the rabbit hole of some specific technology and how it works in at a theoretical level, or like what do you like to see from a meta level?
I think from a meta level, exploring the evolution of something is really interesting, and you guys have done this decently well. So even when you interviewed, I think it was Joe Dolliner, he talked about how their frustrations at Airbnb caused them to start Pachyderm. That was like really fascinating to see that story, to listen to that story. So stuff like that is great. Even at Netflix and Spotify talking about what they had before and then what they kind of had to evolve into was really interesting. The TensorFlow episode, kind of the evolution from disk to belief, TensorFlow was really interesting. I think a podcast and interview is a really good interface and a good medium for discovering that kind of evolution, the war story. I think those are the episodes I've kind of historically enjoyed the most. Just really kind of that context and building that kind of just a deeper relationship and getting into, just like what was that person or team experiencing that led them to, because these technologies were not created in a vacuum. They were created to solve real business problems. And so learning about those problems and how they solve them, I think, is the most interesting thing that Software Engineering Daily has done really well.
Yeah, I think it is the storytelling. I think the storytelling that drives into the technical aspects are what creates a really interesting episode.
Yeah, that's a fair conclusion. Yeah.
So you're a contributor to the Dataquest blog, which has some great posts. One post that I liked gave a really succinct introduction to Spark, and this was really useful to someone like me who basically just reports on Spark and hasn't worked much with it directly. But beyond the raw tutorial style informational posts, you also have interviews that you conduct with data scientists. And when you're talking with these different data scientists, what are the things that you find in common?
Oh, that's really interesting. I definitely think that's a really interesting question.
Or is that as broad as like saying what are the different things that you find in common with software engineers?
Oh, maybe. But no, there's definitely some common things. So I think the most common thing is regurgitated all the time is that, there is, I think people maybe underestimate from the outside looking in just how much time is spent on all the data janitorial stuff. So even if you are working at Facebook, and even if you do have all this infrastructure and stuff, but even spending like 20 minutes to write the SQL query, you know what you want already, but you have to express it in the way a computer can understand it, right? So there's that, there's actually downloading the data, there's like getting it into pandas or whatever tool set you use, and there's a lot of I think maybe people think that it's like a scene from Iron Man and people are just like manipulating data, and it's like, maybe one day, right? But like for now, there's so much time that's definitely spent on just, even if it's not cleaning data, it's acquiring it, it's formatting it, it's kind of all these things. And I think I think that's like the less sexy side of it. So I think maybe it's discussed a little bit less, but I do think almost everyone I've talked to definitely highlight that. We and this is something we do poorly as well, as we don't really highlight that enough maybe in our own interview questions. So it's actually good feedback. But yeah, it comes up quite a bit.
Okay, well let's talk about one of the companies that you've interviewed. You recently talked to Stitch Fix, which uses data science and algorithms to improve the selection of merchandise to clients. Tell me about Stitch Fix's approach to data science.
Yeah, their approach is very interesting. So just a quick overview. So Stitch Fix is basically, if you're kind of a lady and you want if you want to fix where you get clothes delivered to you, you spend like $50 or $60 and they hand select clothes and they send it to you. And they know a lot about your style, your personality, your lifestyle. And they use a combination of algorithms and human stylists to figure out what's the best kind of dress or whatever for you. And I think what's really interesting about their approach is most people in kind of recommend, or a lot of people, I think, when they see a problem like this, maybe are tempted to do all human or all computer. So just completely kind of, Pandora style, just brute recommendations. And I know they use some human training as well, but or kind of just have a stylist pay a lot of money and go to a stylist yourself. And I think what's really interesting about them is they've worked really, really hard to figure out what the balance is. So, and the other really interesting thing is at the I think unlike Netflix or unlike a lot of other companies where the training might be done by humans, but the computer still does the output and the selection. In this Stitch Fix's case, a human actually picks the final kind of dress or whatever they're sending to their clients, which is really interesting because I think that flips the conversation. It's basically, instead of saying how do we kind of just allow computers to better do kind of recommendations, it's how do we allow humans to utilize computers to do better recommendations. And that conversation that kind of mindset is really interesting. And I think that probably won't work in every case, but I do think it's very underrated. And I think there's a lot that can come out of that kind of symbiosis.
Yeah, in Peter Thiel's book 0 to 1, he talks about human-computer symbiosis, and he emphasizes that he thinks it's an underrated idea. How should more people be focusing on how to keep the human in the loop during a machine learning or data science process rather than just automating everything?
Yeah, I think the key I think the biggest thing is remembering that at the end of the day, you're building a product to solve human problems. So I think the focus should be on how do we solve that human problem as effectively as possible, and then these and kind of algorithms like human training. These are all just different tools to accomplish that. I think that's the best way to approach something. Is not to say like, oh, maybe people have been doing this thing manually for so long. How do we automate it? That's kind of like the typical, like, it's like, oh, this like job sucks or it's boring or whatever. How do we automate it, right? And that's kind of the wrong. I think it's slightly misguided. I think in many cases, most of the work is completely unskilled. So if you're an elevator operator, I mean, there's not really like a lot you can do to empower them, if you will. But I think there's a lot of jobs where figuring out how to make humans more efficient, more kind of conversant, and just more productive in general. I think that's like how you think about the problem. Instead of saying like, okay, how do we just replace human judgment or whatever? It's like, how do we use algorithms to, for example, cut down the number of dresses that a stylist has to pick from 1,000 to 10. Because the marginal, and you can, what's really interesting too is if you were to build the opposite, where you actually had like, maybe a human picking some, but then the computer still making the final decision, I think the computer would actually perform vastly worse. And so what's interesting is you can even just it can be a purely business decision where you can say that at the end of the day, a human looking at it and picking a dress or whatever is like, it's just like getting it right is just worth so much money to us that it's like why kind of risk or why kind of allow the computer to do it when the error rate is in most cases going to be higher.
In this interview with Stitch Fix, you mentioned the notorious problem of recommendation systems called the cold start problem. What is the cold start problem?
So the cold start problem is definitely notorious in recommendation systems. It's also very kind of notorious in data science in general, right? So if you want to build a new kind of data science product, usually you need a lot of data already, right? So that's like the interesting catch-22. It's kind of like the chicken or egg problem in social networks, right? It's very similar. So, if you're like Netflix or if you're Stitch Fix, for example, in this case, and you want to recommend clothes or movies to people, and a lot of recommendation engines is a technique called collaborative filtering, where you're kind of looking at joint purchasing decisions that people have made. So like two users are similar, so they might like similar stuff. Well, if you don't have any user data, how do you know like which two users are similar? How do you know kind of like what they both might like? And I think that's probably in recommendation engine specifically, that's usually the hardest part. It's like, how do you give recommendations to someone when they're the first person or the 1,000th person, right? When it usually takes kind of thousands, millions of recommendations to really get kind of to Amazon, Netflix scale to give good recommendations. And they still get things wrong all the time, right?
Okay, interesting. So how did Stitch Fix solve the cold start problem?
I think this ties into their human computer symbiosis approach, where I'm guessing in the early days more and more relied a lot more on the human element. And so like they would have the human stylists actually kind of pick out the dresses. And they would have these surveys that they would give to people, like new customers, really extensive surveys. And they would combine the outputs of the surveys, they would combine the judgments, the final decisions that, say, a stylist made, and then over time figure out how to kind of codify that, how to build kind of machine learning models out of that. I think that's generally like the best approach. Basically kind of just observe. You have to basically find a way to collect that data. That could either be kind of letting people do kind of search and discovery. So maybe you're in the early days of Netflix, you're just kind of on your own. You were just like just searching for movies, whatever. Eventually, they added the recommendation engine because they had the data and they wanted to improve the experience. I think it's like somewhat similar here, where maybe you weren't that data informed at the beginning, and you relied more on human judgment, and then you kind of over time figured out how to kind of build that out.
Okay. One thing that Brad from Stitch Fix said that was interesting was he said that an aptitude for framing problems is as important as the technical skills themselves. And this echoes something that your colleague Vic said in my discussion with him, where he said it's often not so hard to figure out how to find the answer to a question as a data scientist. The hard part is finding what question to ask. Is this consistent with your experience when you're doing data science?
Yeah, I agree a lot with that. And I think, Douglas Adams from Hitchhiker's Guide to the Galaxy knew this the best, right? With his kind of ending part. I mean, it's so true. I mean, there's you can imagine a company like Facebook.
Sorry,
right?
What does Douglas Adams say?
So at the end of the book, they ask like this. They find a supercomputer, the smartest supercomputer in the world, and they ask it like, "What is the meaning of life?" or something, and it just says 42. And so the kind of the takeaway from the book is basically that like the answer, like framing the question is the hard part. Once you frame a question the right way, the answer is actually easy. Which is like really, I think you could probably apply this to any aspect of life, but I think definitely in data science, when you have, you imagine a company like Facebook would have just petabytes, probably exabytes of data, right? Like the hard part is not hiring people to just kind of willy-nilly comb through the data. You would never be able to hire enough people to just kind of analyze every data point and every pattern, It's more of figuring out what signal from the noise. It's more of like figuring out what data is actually important, what actually drives results, what actually affects the kind of bottom line of the business. I think, especially in the kind of quote unquote big data era that we live in, I think one could even argue that the problem framing, problem solving aspects of data science outweigh the kind of big data engineering aspects, or they're at least as important. In the early days, that was not the case. I think you still had to spend so much time. The tools weren't good enough where you could actually kind of focus more on the science, I think. But now, I think the tools have gotten pretty good. So there's a disproportionate focus on framing problems because now it's actually relatively easy to query data or whatever.
Right. Well, I think about Kafka, for example, Kafka being developed at LinkedIn,
Yep.
and LinkedIn developed Kafka partly to deal with the problem of when a user makes an update to their profile, how do you propagate that change to other aspects of the system? And today we'd be like, what? That doesn't sound difficult at all. Being able to
Yep.
maintain consistency among the user's profile and the search engine and different ranking algorithms and stuff, that's not really a problem these days because we have Kafka. And so now that we have Kafka, so now we can ask the interesting questions. So what is the question? So, in the past, I kind of see what you're saying. Maybe we weren't thinking in these terms.
We were bottlenecked. I think we were bottlenecked. And I think because of LinkedIn, I think what is that quote about how like necessity is like the mother of invention? It's totally like, you look at the open source that comes out of LinkedIn and Facebook and Google even, right? Like it's totally totally in line with that principle.
So speaking of Google, Google recently open sourced TensorFlow, the machine learning library. We did a show about this with Greg Corrado from Google. As a data scientist who is on the outside of Google, why is TensorFlow important?
It's really interesting. So TensorFlow, I think the reason TensorFlow is interesting is it's you can think of it as kind of like what Spark did for Hadoop, right? So Hadoop was this giant thing. It was like really hard to install, and then there's all these companies that pop up around it. They have like this loosely based, disconnected ecosystem of products and services and stuff like that. Huge kind of code bases, that kind of stuff. And I think that's kind of like I think that is the role that TensorFlow will play in kind of the machine learning and, the machine learning space and data science space. It is a kind of unified abstraction for working with machine learning models. And I think what's so interesting is they just unify so many concepts. So they have, I know Spotify has that open source project Luigi for data pipelining. And I think TensorFlow, because of the way it's set up, is definitely could take over some of the stuff that Luigi does, kind of building data pipelines. If it's kind of extended, it's not there yet, but I think the way they've architected the product to be this kind of abstraction where you can kind of, it's not really, people talk about it like it's a deep learning library. I think that maybe underscores how interesting it is. It's really That's like saying Spark is just like a, I don't know, big data library or something like that. Just like an NLP library or something
It's
very
a SQL
specific.
library.
It's a SQL library, exactly. But really, it's like a general abstraction of just kind of running machine learning models. It makes it really, really easy for you to write your own models, to specify kind of computations and order of computations as part of their directed acyclic graph. They've done a lot to make it kind of modular, reusable, scalable. They have the kernels for different kind of devices and platforms. It's really it's a well thought out kind of engineering marvel, I think.
We've seen some machine learning libraries in the past. There's Theano and Torch. How do these things compare to TensorFlow? Why was TensorFlow such a breakthrough above these?
Yeah, I think those libraries, I will say, are still really good. So Theano is actually one of the authors of Theano is one of the creators of Theano is one of the co-authors of a TensorFlow paper. And so, like, it's kind of like maybe they were scratching their own itch in the sense of like they kind of saw the limitations of the stuff. I think the main thing is like it's trying to unify the different kind of approaches. I think the main differences are that like Theano, there's Keras, there's kind of 4 or 5 of these. A lot of them are still pretty focused on, it's still pretty focused on more of the advanced machine learning algorithms, deep learning, that kind of stuff. Most of their innovation is around making that like much easier to do. But using Theano or Keras in production is non-trivial. It is quite a bit of work. It's just not. I still think I still see those products as science products. Like they're kind of for researchers by researchers. It's like R a little bit, kind of by statisticians for statisticians. I think it's very similar. It's just like there's obviously people who made it work, but there's a lot lacking. It's non-trivial to make it work within a data center. It's non-trivial to make it scale. And I think the other big question is like how long the support will be, right? Like TensorFlow is backed by Google, right? And unless it goes the way of AngularJS, I think it's like here to be supported. It's here to stay. And I think the shortcomings will be kind of worked out. There's definitely some performance shortcomings. I think those will be worked out kind of over time.
The Exponent podcast did a show about TensorFlow, and in that show, the host, Ben Thompson, who also writes the Stratechery blog, if you've heard of that, he argues that Google open sourced TensorFlow simply because they have the most data, and therefore they can leverage TensorFlow the most, so they might as well open source it to the rest of the community and let the community aggressively update it. I don't know enough about data science and machine learning to know if this is a accurate narrative. It seems pretty cynical. Is this accurate? Do you think this is accurate?
Well, I think it's mostly accurate in the sense of like getting this goes back a little bit to the cold start problem, right? Like it's not like building a recommendation engine is not difficult. Building a good one that works well, that solves a problem very well, is really hard. Like you could build, people build Google clones of Google search engine in a weekend, right? Maybe that's what like Bing tried to do. I'm just kidding, but it's the hard part is that like the reason Google has not been dethroned from search, at least from search, is because their data, right? They have so much data they know when you're searching something, you could be pretty far off, and it's pretty crazy how Google still kind of knows what you're searching for. And that's not because of some kind of unique algorithms that they have. In fact, Google's search team is known very well for not actually being that kind of machine learning driven. Like a lot of the ways they do things is with human training. And they've, it's kind of well known that they're not, it's people even say that Bing, for example, uses more machine learning. But it doesn't really matter because Google has so much data. They have so much insight into what people really want. And I think that that definitely trumps the models. I think the real reason they open sourced it is because they want to. I think there's a few reasons. One is it's great from a recruiting standpoint, obviously, right? Like if you want to work at deep learning, if you want to work on AI stuff, like Google is like the place to go, right? And this is something people have criticized, for example, Apple for, which is they're way more secretive. And so if you're a top AI researcher, you may be less inclined to go to a place like Apple because researchers really like to kind of open source stuff, like to publish stuff a lot. I think the other thing too is there's still a lot of aspects of kind of doing machine learning at scale that I don't think Google is just going to solve magically by themselves by keeping everything secret. So, for example, right, like the cost of like NVIDIA GPUs and their dominance in like the deep learning space and just machine learning in general, I think that like goes to show just how important these other companies and other related industries are. So if you make, for example, if you make it really, really easy for people to run machine learning models, do deep learning on GPUs, that's really great for NVIDIA. That might hopefully help drive the cost down for GPUs, which Google benefits from as well, right? There's a lot of other kinds of things like that where they benefit the ecosystem and then they also get to reap the benefits of their contributions.
Well, this certainly brings us to Facebook, who open sources, what is it, like hardware specs for doing AI or something like that? Do you know anything about that and how significant that is?
Yeah, I unfortunately have not read that much into it, but Facebook has been really good about open sourcing both software, but as well as hardware. Yeah, they're really good about like you can actually go buy, like not buy, you can download a CAD model of their data center, and you can actually get like the same data center like infrastructure set up for you, which is like super interesting, right? Like, and I think I don't know if Google has that, but I know Facebook has taken a lot of efforts to do that. Yeah, it's really interesting. So I don't actually know a lot about. I did hear about it, but I don't know much about what exactly it is. But I do think I think like open source is very, it's really good. If you think about Facebook's mission of making the world more transparent, right? Like if the company is not transparent, then with their projects and their software projects, that kind of goes against that a little bit. So I think these kinds of open source projects are great. I think it's the reason Facebook is able to maintain such a great kind of caliber of engineering talent. If you want to work on the cutting edge of front end development, that's like Facebook. That's like React, right? If you want to work on cutting edge, like deep learning stuff, arguably maybe the hardware side, Facebook's a little bit better now. I'm not really sure. So that's like, it's really interesting.
Okay. So speaking more about like TensorFlow in practice, in the interview with Greg Corrado, he talked about how TensorFlow allows users to deploy machine learning models to a user's phone. Is this anything new, or is the new aspect here just the way that TensorFlow does it?
I think it's definitely not the first time you can run a machine learning model on your phone. Objective-C, Android, these frameworks have machine learning libraries. If you want to do machine learning on your phone, it's definitely not the first time you can do it. I think the mobile thing is twofold. One is I think it kind of shows the power of TensorFlow, which is basically like, you're not making like Theano and then porting it to mobile or kind of making a separate, Miano, like a mobile version of Theano or something, right? With TensorFlow, you're like I think it's to prove a point, in my opinion, which is basically that like this is really a general framework. It is an abstraction. Like, in 10 years, maybe we won't be using phones, we'll be using something else. Like, and like you can just swap it out, just write the kernel, build the kernel for it, and then voila, most of the things will still work. And I think that's their point with it. The other thing though is that so that's one thing. It's just the abstraction and just kind of pushing the bounds on what like a machine learning framework should look like. I think the second thing is that I think we will see more slowly we will see more machine learning being done on the phone itself. Especially as we get more towards VR, AR, that kind of stuff, where it's more real time. You may not really want to wait to get the model updated in the back end. I know like Microsoft and Google both have projects for these kind of huge phones, definitely not like an iPhone or anything, but kind of modified phones with really powerful graphics units that can do imaging of a room, right, just from like a mobile device.
But huge phone, you mean physically huge, or in terms of like the capacity?
I mean, both physical, like it's like really big. It's not a what I meant to say is that it's not like a product you just go buy. It's not really meant for consumers right now. But it's basically like they took a phone, like an Android phone, and stuffed it with GPUs, and they're doing like real mapping within rooms, right? So like obviously, like our current phones are not there. Like, they probably won't be able to do that. But in the future, who's to say that that's not possible? So I think they want to move more towards that over time. I'm still not sure if there's a lot of current use cases that really benefit from doing machine learning on the phone. As you probably know, the performance is not that great. So I'm still a little skeptical that there's a lot you can do with it right now. But I think it's just kind of a bet on the future.
Have you used TensorFlow? Like, have you built anything with it?
I have not personally myself. It's been on my to-do list, but I have spoken to quite a few people who have, including some researchers at Stanford and whatever. And unanimously, they have said that like I'm going to be using TensorFlow.
Wow.
Like for future projects, for old stuff that they're kind of refactoring. Like if you have Piano code, you have Piano code, right? Like it may not be worth the effort to rewrite everything, but there's a lot of people who are quite long on TensorFlow. I think Google is like probably half the reason. Just even the fact that it's going to be supported, hopefully, I guess, and that like there's like a good vibrant community that's going to build up over time. So it's definitely, I have not used it personally myself, but it does seem very promising. Even though it has some performance shortcomings, you can't really do stuff like distributed deep learning yet. They haven't released that yet, but I do think as it gets stronger, it will become very, very compelling.
Awesome. So let's begin to close off a little bit, and I want to shift the conversation towards Software Engineering Daily, because you've been there from the beginning. You've been listening to the show. You've been, with us from the start. So, what can listeners who, maybe are just listening sometimes, but are not, heavily involved in the community, is there a reason that they should, join the Slack channel, for example, or follow us more closely on Twitter, or like, have you gotten anything unique out of the community, or do you mostly just get value out of the podcast?
I've gotten a lot out of the community for sure. I think just getting even closer to you and Pranay has been great, but I think even more just learning a lot, just kind of observing. It's really kind of interesting to see. It's almost like a mini social network. It's kind of like getting to see what others are talking about is really interesting. So like because I'm not a software engineer, like kind of a real software engineer by trade. That's not really my background. I mean, I do write software, but I don't kind of do it professionally. So it's really interesting to see, as someone who does more data science stuff peeking in, it's really interesting to see what interests software engineers, what are the kind of problems that they have, how do they see data science, and what are they kind of excited about. I think the biggest thing, which is kind of, I think, the fundamental point of maybe social networks, is it's just that perspective, just getting the perspective on what people who have, there's some kind of mutual level of interest and trust, right? Like we're not just complete strangers. We all have a shared experience of listening to this podcast together. We have things to talk about together. I think the most important thing is just kind of the ideas that are exchanged, just like people who want to discuss papers. It's just kind of this like natural kind of like chatter board, if you will, of like what's going on, what's interesting, what are people's different perspectives on stuff, seeing different people's reactions to the same thing, or even like, within certain industries that, there's a lot of things about a lot of industries I don't know about. So I'm even like Facebook friends with some of the guys I've like kind of talked with on the Slack community, and I think that's a testament in and of itself, just maybe some of the bonds we've formed there.
So what would you like to see more? Like if you had a vision, if you could spend like 15 minutes and you've got 15 minutes, you've got $2 million to allocate towards Software Engineering Daily, like where would you like to see it go? What would you like to see more of? Or is there a limitation to how much time you want to spend thinking about software engineering on a daily basis?
I think the most interesting thing is how do we kind of how does one foster better discussion amongst kind of subgroups? Or right now, like I think Slack does an okay job with this. It's not really great at handling kind of smaller discussions. I mean, yeah, you can make a channel, fine, but it'd be really cool, like to have like it'd be really cool to have kind of like short-term discussions, maybe like a day, and then it just kind of stops, right? So like something happens, it's like maybe it's like similar to Hacker News a little bit, where it's like something happens, like someone exposes some Theranos thing, or Jeff Bezos does something interesting, and people like seeing people's reaction and just discussing it is really interesting. And like that used to be great on HN, is no longer the case. You like don't really feel like commenting on Hacker News anymore, and you also don't have anything in common. I don't think you have anything in common with the other Hacker News people. It's so big now. The community is so big that it's just kind of this like faceless avatar network kind of. I don't know. Versus I think on SE Daily, I think there's a lot of community, but there's just no like shared respect and mutual trust that I think SE Daily can definitely kind of keep going because of that just community feel. I think kind of figuring out ways to build like smaller temporary groups, or maybe moving away from Slack entirely. If I had $2 million, I would ideally like to build my own kind of community software that was like 100% focused. That was like a little bit modular, but very focused on the needs of like software engineering daily. How do people, even discussing, right now, if you want to discuss something, you have text and images that you paste, right? Like, but how do people kind of like interactively explain stuff? How do we, have like little, I don't know, Periscope video stuff? Just allowing more forms of discussion besides text is really interesting to me.
Maybe like Product Hunt is the model I should be looking at.
Yeah. Even though I think they have the same issue there too, which is like, it's just like, thankfully they do have like, you like say who you are. It's not just like random people, random usernames. So maybe that's why they've solved that with identity a little bit. But yeah.
Cool. Well, Srini Kadamati, thanks for coming on to Software Engineering Daily. This was really interesting talking to you. You are a valued member of the community, so so thanks for coming on.
Totally. I enjoyed it.